So let me continue with number 16, and I think it'll be a little bit easier to see now, or at least 19 will be a little easier once you understand 16. So 16, part A asks you to use phi to define to define star, so that phi is an isomorphism, and phi, you'll recall, goes from z with ordinary addition to z with star. And in part A we mapped this way, and we defined star so that phi was an isomorphism. Well, part B actually asks you to go the other way, which is z with some undefined operation mapping to z with ordinary addition. And the first problem you might have with this is you might say, well, phi doesn't go the right way. But notice that since phi is 1-to-1 and onto, as a set map, it's invertible. Remember, any set map that's 1-to-1 and onto has a well-defined inverse. So Fraleigh doesn't say it, but he really means that you want to use phi inverse going this way. So we're still using phi, which, since it's a 1-to-1 and onto map, has a unique inverse, so that we can still talk about using phi and making phi an isomorphism, or making an isomorphism from z with star onto z with plus, with ordinary addition. Other than that, there's not very much interesting going on, but let's see what phi inverse does. So let's just look at phi inverse of, say, 5. So phi inverse of 5 should be what? It should be the thing that phi maps to 5. In other words, it's 4. And that's because phi of 4 is equal to 5, right? And we could also examine phi inverse of 7, which is, of course, equal to 6. And now we want to, I'm going to skip a few steps here, because I think if you got the first part of 16, you'll understand the second part. And I'm just going to consider phi inverse of m plus n, or m star n, and that will be what? Well, it should be, if it works correctly, it should be, as an isomorphism, it should be phi inverse of m plus phi inverse of n, right? That's the operation on this side. We know what phi inverse does to m. It subtracts 1. So this is m minus 1 plus n minus 1, which is, of course, m plus n minus 2, so that phi inverse of m star n has to be m plus n minus 2. So I'm going to conjecture make a conjecture that the operation we want is m plus n minus 1. So if I do that, then this would be equal to phi inverse of m plus n minus 1, which is of course m plus n minus 2, and notice that is equal to that as required. So I want to define star as m star n is equal to m plus n minus 1. So that settles that. And there was one more issue. Let's see, I can't remember what the other issue is that I was gonna. Oh yeah, I remember what I was gonna say. The identity element for star, as defined in the second half of the problem, is 1, and that's because m star 1 is always equal to m plus 1 minus 1, which is equal to m. So m star 1 is always equal to m, so that's the identity element. And if you watch the first video, you can see that for part A of 16, the identity element for star, remember it's defined differently in the first half than it is in part A than it is in part B, is minus 1, and that's because m plus m star minus 1 is by definition m plus minus 1 plus 1, which is equal to m. So I operate on m by minus 1 and I get m back. That's the very definition of an identity. So I'll try and do 18, but I might not get to it until